Hello everyone. In today's lecture we will discuss about the temperature sensor used in the automobile industry for the measurement of the various temperatures. So temperature is an important parameter throughout the automotive system. In the operation of an electronic fuel control system, it is important to know the temperature of the coolant, temperature of the inlet air, and the temperature of the exhaust gas. The temperature sensor for any given application is designed to meet the expected temperature range. That means that temperature sensor work on some reference parameters, that there are some input data through which the measured reading is taken a reference value. For example, a coolant temperature sensor experiences far lower temperature than a sensor exposed to the exhaust gases. So this is typical example of the temperature sensor which we used as a coolant sensor. Here you can see that the outer structure is shown, which gives you the temperature sensing element, and there is some electrical connection. A typical coolant sensor, as shown in figure, consists of a thermistor mounted in a housing that is designed to be inserted in the coolant stream. This housing is typically threaded such that it seals the assembly against the coolant leakage. Might you all have seen that how the spark plug is fixed in case of the two-wheelers, maybe bike or scooters, that it has threaded system. Once the threaded are screwed up, then it makes a connect with the next part. Similarly over here, this temperature sensor has some threads over here. So this temperature sensor, when joined with the coolant stream, that time these threads insert inside the system and it completely locks the housing, because it is going to measure the coolant temperature, so it need to prevent that coolant should not come out of the assembly. A thermistor is a two-terminal semiconductor whose resistance varies inversely with its temperature. The theory of operation is based upon the influence of temperature on the charge carrier concentration, which in turn depend on the difference in energy between the valence and conduction pen, and which are an exponential function of temperature. So basically a semiconductor material is used here, and such material has a property that when the temperature will increase, then resistance will decrease. That means there is an inverse relationship between the temperature and resistance. And now consider that when resistance is varying, then it will bring a change in the voltage, or we can say that a potential difference will change, and with that calibrated reading we can get the assumption about the temperature. So the resistance of a thermistor is a nonlinear function of temperature that can be modeled over a given temperature range by a polynomial function of temperature. So here a logarithmic function is given, that logarithmic change in the resistance value is equals to the A by T minus B, where this A and B are considered as the constant value which we used for particular semiconductor material which we use as a sensing element. The sensor is typically connected in an electrical circuit like that shown in figure, in which the coolant temperature sensor resistance is denoted by RT. So we are considering that reference value of the material which we are using for temperature sensor, its resistance is RT. So this value is a reference, and now when we use it for temperature sensor, then whenever the temperature is going to change, we keep a record that how much temperature is changing in reference to this particular value RT. This resistance is connected to a reference voltage through a fixed resistance R, and here a circuit diagram is given where you can consider that this is a fixed resistor R, this RT which keeps on varying, and it provides a terminal voltage VT, and it gets a reference voltage V so as to work in the system. So how to calculate that terminal voltage VT? This formula is given here. VT is equals to V multiplied by I RT divided by R plus RT. The sensor output voltage is VT. The combining the above two equation, one is for the logarithmic RT value and this voltage VT value. VT is the terminal voltage and RT is the terminal resistance of that sensing element. Combining on these two equations, we get that equation for temperature, which is given here. A by that complete set, B plus logarithmic value of VT into R divided by V minus VT. So here this terminal voltage is input to the digital engine control system via analog to digital converter. As we have discussed earlier, that with the sensor we use some kind of electronic circuit, and here the circuit name is the analog to digital converter, which convert the analog values into digital form. So with the help of the RT, it is possible to convert VT. So in the upcoming lecture, we will discuss about the NOx sensor used in the automobiles. Thank you.